Phagoflux is developing leading-edge sensing technology to measure the process termed autophagy. Autophagy in layman's terms means self-eating. It indicates a process where cells degrade their material. Phagoflux aims to develop technology that can be made available for the research and pharma environment where the aim to measure autophagy activity is highest. In the long term, Phagoflux wishes to make this technology available to the diagnostics and the wellness market, where autophagy plays a major role. So, when we look into cells, we see that the cell is filled with these vacuoles. They're termed autophagosomes. These autophagosomes collect cargo that needs to be removed. Once that cargo is collected, it will be brought to lysosomes, other organelles where the degradation takes place. Now, this process is of course very active, and hence it requires to measure an activity. Phagoflux aims to provide sensing solution that can capture and measure that activity in an easy, accurate and very rapid manner.
One of the current techniques used to measure autophagy activity is Western blotting. This typically takes between 2 and 3 days and is incredibly cumbersome. When trying to assess increase or decrease in autophagy activity, it introduces a large margin of error.
The research conducted by the Phagoflux team focuses on developing technology that can accurately quantify and monitor the autophagy process in cells. And the measurement of autophagy activity is based on an analytic method developed by our team with a fundamental contribution by Dr. Andre du Toit.
The application of this technology, specifically in the medical field, applies to the ability of the Phagoflux technology to inform us about the wellness of cells. This unique solution to measure the self-cleaning process rapidly, accurately and cost-effectively allows Phagoflux to bring this crucial metric of cellular health to the market. It has particular relevance in diseases where autophagy is dysfunctional, such as in neurodegeneration, but also in diabetes and cancer. Because these cells cannot undergo autophagy, toxic materials build up and the cells eventually die. This is evident in diseases such as Alzheimer's, multiple sclerosis, but also plays a major role in accelerating the rate at which we age.
Monitoring autophagy and its activity with the Phagoflux device will, for the first time, make it possible to accurately quantify the effects of lifestyle choices that are known to change autophagy activity, such as exercise, fasting, and diet, most notably a diet low in carbohydrates and high in fatty acids, or a keto diet. This is critical in monitoring the risk factors that are associated not only with aging, but also with obesity, insulin resistance and diabetes, and even medications, such as those prescribed for neurodegeneration and cancer.